Thanks for everyone for coming. How's everyone's day 2? Good? Yeah? I hope you're not too exhausted yet, and we hope not to keep you too long because I know there's beer and free food and stuff going on in the community hub, so we won't keep you too long. But thanks everyone for coming. This is Living on the Edge with Spring Cloud Gateway, so we're going to talk a little bit about Spring Cloud Gateway. My name's Ryan Baxter. I'm a software engineer on the Spring Cloud team, and I have the honor of presenting with Cora, and I'll let her introduce herself.
Thanks, Ryan. My name is Cora Iberkleid. I'm a platform architect out of the New York City office with Pivotal.
Awesome. All right. So we got a lot to go over, but first we're just going to level set a little bit with what a gateway is, some of the concepts behind it, and then we're going to jump into some demonstrations, which is more interesting stuff. So I think we're all familiar with what microservices are today, and if you have this very simple architecture here where you have 3 microservices, A, B, and C, and you have a couple of client-side applications that need to talk to those microservices, you can see this gets a little complicated, right? We have a lot of arrows going back and forth, and it's also very fragile, right? So if something in our microservice architecture changes, there's a pretty good likelihood we're going to break someone on one of our clients, which is something we don't want to do, right? So this kind of makes us want to barf. But when we introduce a gateway, we can see that this picture becomes a lot cleaner, right? All of a sudden, a lot of those arrows go away, and we introduce this abstraction layer between our clients and our microservices. So this has a lot of benefits, right? And a lot of them we're going to talk about, but the main benefit here, as you can see, is things are a lot less fragile, right? And it allows us some of the promises that microservices give us as far as agility and speed, right? Because I can now change my architecture as I see fit and as my business needs demand, and I'm not going to necessarily break my application, my client-side applications, because those clients are talking to the gateway. The gateway kind of insulates them from what might be happening behind the scenes. So there's a lot of responsibilities that a gateway has besides just routing. We can do a lot more there, and a lot of these we're going to talk about today and demonstrate in demos later on. So besides just routing a request through a gateway, what else can we do? Well, a popular, something that's pretty popular to do at a gateway is to also have some type of security, right? You have a single point of entry, so it might make sense to provide some security there as a common authentication for the applications that are behind it. Also, because you have this single point of entry, it's great to monitor things, right? You can see all the requests coming into the application. You can see everything that's flowing out of the application. And it's a great place to collect a lot of logs about what might be happening as our clients hit the application. Canarying is also a very popular thing to do at the gateway or with a gateway. So for those of you not familiar with that strategy, it basically involves deploying 2 different instances of an application and then routing traffic to one of those instances based on some property of the request, right? Maybe the user that's logged in or some type of header that's coming in on their request, or maybe the time of day or the location that they're coming from. Monolith strangling. So for those of you that are still transitioning to a microservices type architecture, there's a pattern called monolith strangling where basically you stick the monolith behind the gateway. And as you make that transition to more of a microservices architecture, you take off chunks of that monolith and you implement them as microservices. But that can all happen transparently to your clients, right? Because the gateway, again, is insulating everyone from that transition. And then resiliency, right? In an ideal world, everything's going to run great all the time. We're never going to have any failures. Nothing's ever going to go wrong. But we all know that's not true. So when something does go wrong, there's an opportunity here at the gateway to kind of insulate our clients from potentially seeing any problems that might be happening downstream. So from a Spring Cloud perspective, as some of you might know, we previously had Spring Cloud, inside the Spring Cloud Netflix project, we were taking advantage of a project from Netflix called Zuul. And that was a decent gateway for basic requirements, right? But as soon as you start to get into more complex scenarios, it becomes a little hard to work with. We completely realize that. And Netflix had announced that they were coming out with a next version of Zuul called Zuul 2. But at the time, we were thinking about doing something else besides Zuul. They had no solid plans around when that was going to be released, et cetera. So at the same time, while we were thinking about what to do next as far as a gateway, we had a lot of stuff going on in the Spring ecosystem, right? We had Project Reactor with Spring 5 and Spring Boot 2.0 and this whole new reactive stack that was coming out along with the new web framework WebFlux. And the combination of all those things provided a nice foundation to build a gateway upon, right? Why is reactive or an asynchronous architecture good for a gateway, right? So one of the key benefits of non-blocking I/O is that it uses a lot less resources for us, okay? So if you imagine what's happening at your gateway, you have the single point of entry, there's a lot of traffic. In a servlet model, you have every single thread needs to handle each incoming request. That can add up as far as resources to handle all that load. Well, in a non-blocking architecture, like with Project Reactor, we have this model where each incoming request gets stuck on a queue, and then there's a couple of threads that go around and handle those requests and then process them asynchronously. So they sit on the queue until someone's ready to handle it, and then that goes off and makes a request, and then we keep on processing incoming requests, waiting for responses to come back, and as the responses come back, then we ship them back to the clients, right? And this allows us to handle the same amount of load, but with far less resources. And less resources means less money for you guys. So a reactive gateway is a much better architecture because it has potential cost savings for you, and everyone likes that. So inside Spring Cloud Gateway, we have a couple of core components and ideas and concepts that we're going to try and illustrate today. Right, so inside the gateway, a client makes a request, it ends up into the gateway. The first thing that's going to happen is it's going to hit this handler mapping component. And this handler mapping is going to look at your route definitions and all the predicates defined in there and decide if there is a route that's able to handle this incoming request. So it's going to go through each route, look at the predicates, decide if each one of those predicates is true, and if it is, then that's the route that's going to handle this request. If we do find something that matches, then we move over into the web handler, and this is where the filters are actually going to be applied to the requests. So the filters are, we have the concept of pre-filters, which can manipulate the request before it is proxied downstream. Then we have a concept of global filters, and these are filters that apply to every request, no matter what, whether you define them or not. And they typically handle core things like routing the requests. So we'll talk a little bit about that in a second. And then after the request comes back from the downstream service, we have this concept of post filters, which they have the opportunity to manipulate the response in some way before it heads back to the client. So from a predicate point of view, the cool thing here is that you can pretty much match on any aspect of the request. So path, host, date, time, cookies, query parameters, anything, the body, all that stuff. That's pretty cool, and it's a big enhancement over what Zuul could do. Filters, again, you can match on all aspects of the request. Whether you want to match on path, incoming headers, you can match on the date and time that the request comes in. You can do cool things like rate limiting and apply circuit breakers with hystrix, which we'll show a little bit in the demo. Again, anything here. And then global filters, we have a couple. Like I said, these are applied to all requests, and they handle core things like actually routing the request. So if you're routing an HTTP request, we use this Netty routing filter, the Netty HTTP client to do that. Cool thing here, we can handle WebSockets proxied through the request, whereas before that was pretty challenging to do with Zuul or impossible. Then we have a load balancer. So if you want to load balance requests between multiple instances, which we'll see in the demo, that's possible and done here. And then obviously we can collect metrics at this point as well. And then similar to the pre-filters, we can apply those post-filters, similar stuff. You want to modify a response header, you want to set a status, you want to add a header, you want to remove a header, you want to add cookies. All this stuff can be done as a post-filter. So now I'm going to hand over to Cora, and she's going to talk about different architectures.
Okay, thanks, Ryan. Yeah, so there's a few different ways you can deploy the gateway, a few different choices to make. So this example shows an embedded gateway where you simply add the gateway libraries right into your POM file or into your Gradle build file. It's part of your app, and so there's no extra latency. So, it's good for those use cases. A slight variation of the use cases to embed the gateway in an app that's kind of like a data access object in that the responsibility of the app is to talk to a particular system. And if that system happens to be maybe a fragile legacy system, or if it's a pay-per-use system where you want to control the amount of requests you make to it, even as your consumer application scale or even as this app scales, you can have very fine-grained control over that by rate limiting in an embedded gateway. Another option is to implement a gateway as a separate application, which works as a facade. This is great to increase your security posture because then you can expose the gateway to the outside world, but you keep the routes to the backing apps hidden from the outside world, and it's only the gateway that has access to those applications. And it's also polyglot compatible. So if your downstream application is Python or Ruby, this will still work. It's also good if your application is a monolith, as Ryan was saying, you start to break it into multiple services, and the API you want to expose to the client can be a consolidated view of all of these broken up APIs. So it's really great for shielding the client and presenting a better API, and also for cross-cutting concerns. So if you want to implement authentication or authorization and prevent every developer or every development team from having to take care of that concern, you can put it in a common gateway and simply have your developers leverage that. And of course, there's a combination case, right? There's cases where you might want to use that app-specific gateway as you refactor a monolith and still have a common gateway for things like security. And so that's valid. And of course, in this model, you can also add the embedded gateway into any particular application where you need that control over some pay service or fragile backend. So back to Ryan for the beginning of a demo.
So now we're going to do the demo, and my colleague Ollie told me it would be a shame if we didn't have some reference to Aerosmith given the title of this talk. So here's my GIF of that. It's from their music video, apparently. Okay, so this is the demo architecture, or the architecture of the demo application here, right? I know it's mind-blowing. It does a lot of very cool stuff. But so there's two services here, a blue service and a green service. And as you might expect, those services just return either the color blue or green. Nothing crazy. And then there's a front-end app that serves up some JavaScript and HTML that calls one of those back-end services and displays the color blue or green, depending on which service ends up getting, the request ends up getting routed to. Then we're using service discovery, so everything's registering with Eureka. We're taking advantage of the load balancer and the gateway to load balance between the blue or the green service. Okay, so let me show you what that looks like. Yeah. So I have it running on my local machine here. So if we go to this port, and of course, I'm going to start off this demo. Super cool. All right, so you see green. I'm going to also show you something. Oops, not memory network. I'm going to show you something else here. It's blue, green. But you see every once in a while we hit this blank page that seems to take forever to load, right? We see this time. It eventually shows green, but it takes 5 seconds to do that, right? So why is that? Well, it's to illustrate a specific point here. So I have, if you can see, I know it's a little tiny. I really can't make this bigger, but we have a green application running, a blue application running, and then I have this thing called the slow green application, which is the green service, but when you hit it, it's very slow to respond. So because that's not the best user experience, we can kind of insulate our clients from that slow service at the gateway, just in case it happens, right? Hopefully we're going to address the slowness at some point, but we want to insulate our clients a little bit and help them have a better user experience. So this is the main class of our gateway, and this, can everyone see that code, by the way? Yeah? Okay. This is this one bean here is the definition for our routes. So you can define routes either in Java API or via configuration properties, either way. I find the Java API works a little bit better in demos, but So that's why I'm doing it here, but you could also do this in configuration properties. But basically what this is saying, you can see we have 2 routes defined, and we're basically routing based on path. So when there's a request that comes into blue or green, we send that request off to a service called blue or green. This load balance protocol, LB protocol here, basically tells the gateway that what's following here, this host name, is actually a service ID, and to actually look that service ID up from service discovery and then decide where to send the request, okay? Similarly, here we have another route definition that says if we come into the root, or we come into /color, or we come into /JS, I want you to route that request to a service called blue or green front end, okay? It's very simple. So this happens to be the route that's can potentially be slow. So what we can do here is add a circuit breaker to this route, right? So we can add a filter to this route, and we have a filter here called Hystrix, right? So this Hystrix, for those of you who don't know, is a implementation of the circuit breaker pattern. And this takes a configuration object that all it really needs right now is a name. So we're just going to call it command for now because it's not particularly important. And if I restart this application now, make sure I restart the right one. And the gateway starts back up, and we refresh here. We see green, we see blue. Okay, now we hit that slow instance, and you can see we got a response faster. It only took 1 second, but we got an error, right? So if we look at the response, actually what we got back was a 504 gateway timeout. So I'm not sure, while the response came back quicker, I'm not sure if this is really a better user experience, right? So we can take this a step further. So Hystrix has the concept of fallback. So when the circuit breaker is tripped, we can fall back to something else to actually send a response back instead of a 504, right? So I have this mapping down here called color fallback, right? And all this does is instead of, we'll return the color red instead, okay? So basically we're gonna say if this circuit breaker is tripped, we're gonna set the fallback, and the fallback is basically going to forward the request onto /color fallback here, okay? And then now if we restart, we should be able to demonstrate this. So we see blue, we see green, and there we see red, okay? So instead of getting a slow green response, or instead of getting a 504 back, we now get actually something back instead of just this terrible user experience. So just jumping back to the slides quickly, which are over here. What if we wanted to add in this yellow service, which returns yellow? But I don't just want anyone to be able to access this service. I want people with, or users with special privileges to access this service instead. So Cora is going to tell us a little bit more how we can actually implement that functionality in the gateway.
All right, thanks, Ryan. Okay, so we're going to add a yellow service only for special users. But first, I want to review generally what we want out of this application, what each different persona wants out of the application. So as a consumer, I want the features in accordance with my subscription. So if I am a premium user, I want to see that yellow. And if I'm a trial user, maybe I don't get as many requests as a premium user. But we want to be able to offer membership plans and honor those SLAs. As a developer, I just want to be able to focus on my app. I want to write my blue-green app, and I don't want to have to worry about what rate limits go with what user plans, or how people sign up, or how to authenticate people. As a product owner, I want to ensure that all of my consumers have a uniform and consistent experience. So whether the developers of the blue-green app, or the developers of the weather app, or the stock app, I want when they build their application, when a consumer signs up to that service, I want the consumer to have a consistent experience. And as an operator, I want whatever solution is developed here to be resilient and scalable. So let's see how we can make everybody happy. Consumers, so we're going to define 3 subscription plans for consumers. We're going to have a trial, a basic, and a premium plan. And you can see in our configuration file, we're setting different rate limits for each. So if you're a trial user, you just get 2 requests a second. You can be a premium user and get much more. And also, if you are a premium user, you will be able to see that yellow service. For developers, as I said, just want to focus on their code. So they want all of these things given to them as a service, access to something that will do the authentication and authorization, do the rate limiting, enrich the request so that by the time the request is forwarded to the blue-green app, the app will know if it was a premium user or not, and take care of all of that forwarding. As a product owner, you want to ensure that your developers have access to all of this in a very easy way, that they know where to go to get the gateway, how to bind to it, and that you have sort of an operationally easy way to upgrade the gateway, et cetera. So for this, we're going to be implementing the Open Service Broker API, which has these concepts of a catalog of how to create an instance and how to bind an instance to your, in this case, to your route. Normally you bind, or more classically, you bind a service to your application, like a database to your application, so your application can talk directly to the database. But in this case, we're going to bind a service to our route so that the router sees that a user is trying to get to a certain application and redirects the request to our gateway first. So keep this sort of in mind, and I'll show you a little bit of insight into the catalog that we've defined. And operators are going to want resilience and scalability, meaning that if the gateway or the service broker have to restart or have to be upgraded or replaced or crash, then when the process starts again, that it'll be able to recover all of its state. So when a developer says, give me a new instance, CF create instance, we're going to store that information in a Mongo database. With the reactive libraries. And we're also going to be using Redis so that when the gateway scales, the rate limits are applied across all instances. So if a trial user is allowed 2 requests and we scale to 2 instances of our gateway, we're not allowing them 4 requests because we're not conscious of the other instance, but rather that state will be stored in a common Redis, and we will still be limiting the trial users to 2 requests per second per user. So let's see this in action. So this is all deployed on Cloud Foundry. So here's the blue-green app, the same app that Ryan just showed you. And what I'm going to do is log in. So you can already see it's asking me for a login. So you can already see that the gateway is intercepting the request and asking me to authenticate. So I'm going to log in first as a basic user. And I get blue, and I get green, and blue, and green, and everything is happy. Now I'm going to log out. And I'm going to log back in as a premium user. And I expect to see blue, and green, and yellow. Right? So obviously the gateway has informed the blue-green application that I'm now logged in as a premium user, so the blue-green application can return that yellow color. So let's move over to Cloud Foundry here. And right now we're in the space, so I'm going to demo this with a cool app. It's a very simple app. All it does is return a string. We have the broker gateway application deployed. And right now, you can see that the broker gateway actually uses Redis for rate limiters and Mongo for service instance information. But right now, we don't have any service instances that actually represent the gateway that a developer could bind to. There's nothing in the marketplace for the developer to choose quite yet. So let's take care of that. So first, let me show you this route surface application. I'm going to go to an endpoint that is related to the service broker, Open Service Broker API. And I'll authenticate as admin in this case. So you can see here, it's a bit hard to read, but you can see here that this is the plan that describes what is going to be shown as the catalog when I add this to the marketplace. So let's go ahead and do that. All right. So I'll show you the command. Normally, you would have an admin do this, and so you wouldn't need to have the, I don't have admin access on Pivotal Web Services where I'm doing this, but we're just going to run this create service broker command, where the name of it is route service demo, the admin super secret credentials that I just had to put in through the UI, I have to enter them here as well, and the route to this application. So once we do that, we can go back to Pivotal Web Services, go back to the marketplace, and we can see that now we have this service available through the marketplace. Pretty simple. So now as a developer, I can select this one plan that was there, and I can create an instance of it, my subscription gateway. And actually, just before I do that, I'm going to show you one last thing, which is I'm going to send a request to my Cool app application. So it's working, cool as a breeze on a hot summer day, and you can see the kind of HTTP headers that come back in the request. And I didn't have to authenticate. So let's finish up that setup. So I'm going to say, go ahead and bind this to that Cool app route and create that. So now I've got my service in my space now, and if I go inside of here, I can see that it's bound to my Cool app. So now when I go back to the command line, if I try to just rerun that command, it's going to say unauthorized. So what I do is I can log in as a trial user, for example. And now I'm authorized, and it worked, cool like a fool in a swimming pool. And you can see that there's these extra headers that tell us about the rate limiting. So, so that's good. That's all working. And if I log in as basic, I have higher numbers. So as a trial user, I only had 2 requests per second allowed. And as a basic user, I have higher limits. And the premium have even higher limits. So let's see what's next here that I wanted to show you. OK, so let's send 5 requests. Let's log in as a trial user, and we'll send 5 requests in a row. So you can see that it didn't allow all of them to go through, right? Some go through. This one went through, for example. And then some are actually rate limited. So I'm going to leave some time for questions, but I do want to mention you could scale the broker application, and the rate limits would be honored equally because of Redis. And I could restart the broker application as well, the broker gateway application, and it would just continue to work as normal. It would pull back all of that service instance information from MongoDB and rebuild those Redis rate limiter objects, and it would work as well. So if you needed to upgrade the broker, you could maybe apply some kind of blue-green strategy, and the consumer would be none the wiser. So let me go back to the slides. So I guess that's the end, really. So let me back to present. We do want to thank. We've had a lot of people help us throughout this. Scott Frederick, Spencer Gibb, Madhav Sath, and Rob Winch. I know at least 2 of you are here. I can't see because of the light, but thank you so much. And thank you, Ryan.
Thank you, Cora.